Great. Good. All right, my friends. So today, did I like send out a little? I did send out a little email about today, didn't I? Yeah. And the reason it took so long to send an email is I had to actually sit down and create the mailing list, because it's actually, I have to do it by hand, which is dumb. But what I would like to do today is do a couple of problems together. I don't want to push forward content-wise, but what I would recommend is that for Wednesday, you start to read, I think it's section 1. Does anybody have the book up actually? Now I'm kind of wondering what it is I want you to read. It's the next section on numerical methods.
Analyzing equations of numerical.
Yeah, what section is that?
1.4.
1.4, cool. So friends, if you could, for this, just start reading this. If you could, God, the board is a mess. Thanks, person who didn't clean it. It's half me. All the black writing. So yeah, just if you want to be ahead, section 1.4, and I'll have a new assignment opening up for us on that. This is just basically, how does a computer, how do we get those lines when I click on the D field? How do I get those beautiful curves? And how do we make those curves better? But we'll start off with the simple thing. And so really, if you just understand the basics of Euler's method, you're going to be rocking it. Otherwise, today is going to be kind of catching up. But before we do anything, let's actually check in on life. Do I have tea? Okay, can't have life without tea. So I just ask you, friends, just please stop doing whatever you're doing for one little bit of your day, and maybe shut your eyes. Now, one thing we could do here is just let go and veg out as much as possible. But another thing we could do is just kind of notice what is happening here right now. There's sounds, and there's wind currents, air currents. There's also currents in your brain, all sorts of things moving around in that space. One of my favorite Zen practices is focusing on a koan. A koan is a riddle that is intended to kind of break your brain open. And my favorite one is, what is this? And we can ask this about anything we're doing or anywhere we are. What is actually happening at this moment? And if we get bored in life, we're sitting around and we're bored, generally that's a sign that we're not paying attention to what's going on. At any instant, there's an incredible mystery unfolding before us. Yay, life. We live. Or so it seems. Cool. All right, friends. So let's see, that is not what we're doing. We are not doing lines. We're not doing lines like we are in business calc. We got a different thing going on. So I wanted to give you a reverse problem. I want to give you a direction field, and I'd like you to come up with a differential equation that models the direction field. So this is just warm up. And then I'll go around and we'll do a few things together and then we'll finish up what you gotta finish up. But let's say I got X and Y, and what I'm looking for is Y prime equals, this will be an autonomous equation over here. I've got an equilibrium solution at Y equals 1. Above that, the slope is positive, starts off pretty chill and gradually becomes more intense as we get further away from Y equals 1. And then we have an equilibrium at 0, at Y equals 0, so straight across like that. And inside here, this is actually all positive in here. So the solutions, I'll sketch one out in a second, but that's the general feel of the direction field. And then down here, everything is negative in slope. We move down. Take a minute, can you come up with this side? Y prime equals what over here? There's infinitely many answers. Pick the simplest one that you can figure out. And a midway point would be to sketch the relationship between the slope and the y coordinate. That's where I'd start, and then I'd come up with a formula. It's okay. Okay, got it. Got it. So you were multiplying by negative y. Yeah. So let's see here. I don't think this works. Actually, let's see. So when y is large, let's say like y is 2, I've got it. You're going to get a negative out of that. I think if you draw that first, you might see what you're missing. There is a little subtlety. Yay! I'll get some light up here for y'all. Step 1 is noticing where the equilibrium solutions are. There at 0 and at 1. So that means the derivative y prime is 0 when y equals 0 or y equals 1. That's part of the process here. And then I would note what the slope is in the various regions. So over here, it's positive. And as y gets larger, it looks like it gets steeper. Inside here, it's also positive. Now I'm gonna just fake this out. I don't know what the curve is gonna look like. I'm just faking it. So I'm just getting a sense of what this all looks like. Does that make sense, what I have there? Tell me if you see the correlation, because this is what I'm really trying to do, is practice this correlation between direction fields and this diagram here. Do you see? Does anybody want me to talk this through? Let me know. It's really important that we know this. Was that a yes, talk it through, or yes, you got it? Yes, talk it through. Okay, awesome, cool. And yeah, same, cool. So here we see that y prime is positive when y is bigger than 1. And y prime is also positive when y is between 0 and 1. But there's something that happens in that transition, there's this equilibrium that we have right here. So when y is bigger than 1, and here's 1 right here, y prime, this isn't the solution, this is a graph relating the position, the horizontal position, excuse me, the vertical position to the slope. So here, when y is bigger than 1, y prime is positive. When y is between 0 and 1, y prime is positive. So if I write it that way, does that help at least see, you know, Lou, does that help there?
Is there any like visual correlation?
Yes.
Cause I see like along the y-axis, there's the kind of like, if you like take that hump with the arrows on the lower and then the upper, it like kind of forms that right there.
Yeah, so this is really, this picture kind of turned on its side.
Yeah.
And so definitely that. And we've got these equilibrium solutions marked off. So you could take this axis and twist it down like this. And then notice that in this region, I am positive. In this region, I have positive in terms of slope. But down here is negative, and I haven't sketched that piece yet, so let me do that. When y is negative, the slope is negative, and it looks like it's getting more negative the way I did it. So this region over here is when y is less than 0, where y prime is a negative number. Is that all cool? So now, if I'm going to actually come up with an equation for this could work, but man, that's probably a hard one to come up with an equation for. So I'm going to make it smoother. Watch this. So I'm going to make this thing go like this. So I'm making it just bounce off of 1 like that. That's still 0. There's y prime, and there's y. I don't know why the word no was there. Probably some gas or something. So I'm just making it look like a polynomial, because that's not a polynomial. So now let's think about it. What could this possibly be? So here y prime equals, and for each of these zeros, I'm just going to add a term over here. So there's y's times, well, watch what I'm going to do here, y minus 1, and then I'm going to square that term. So why am I doing this? Because I want y equals 0 and y equals 1 to be zeros. And if you're going to bounce off of a 0 like this, that term has to be squared, or at least an even power. If I put 4 here, that would totally work. In fact, I could put an odd number here and an even number there, and this graph would look essentially like that. It'd be steeper and all sorts of stuff down the way. But right now, this works completely. If you plotted this out, you went to Desmos, and you plotted out y equals x times x minus 1 squared, you would get a cubic that looks a lot like that. So this could be one of our solutions. But there's other possibilities. Did anybody come up with something different? So there's a lot going on in that process, but we pull this in a completely different direction than we have so far. How would I solve that differential? Look, let's just say I asked you, okay, now solve this. What would we do? And have I even started recording? Hopefully. Am I working?
Yeah.
Yay, okay, cool. It would suck to not be recording. Somebody help me out? How do I solve that differential equation?
Would you want it in terms of x?
I would, so yeah, y equals some function of x. How do we get there?
Just use separation.
Separation, like literally, we only know one thing so far. So if I wanted to solve this, I would do dy. First I'd convert that into this. Then I would separate. We get that. So now we integrate then, right? So integrate. Right side becomes x plus c. I love that. How do I do that? Any ideas, suggestions? How do we do that integral?
Just turn it, the exponent into a negative.
We could definitely do that. That'll end up, nothing wrong with that approach, Lou, but it'll end up, I think, making life miserable. So I've got a fraction. Oh, yeah, Corey.
Is that where you do that a over y plus b over y plus minus 1 squared?
Definitely. So partial fractions I would have to pull in on this one. So if I was doing this, let's just say integral of dy over y times y minus 1 squared. What I would do is first write this inside as a over y plus b over y minus 1. And since we've got a y minus 1 squared, we've got to allow it, that's one of the possible denominators that could get us there. We would figure out those coefficients, whatever they're going to be. I don't know what they're going to be. Do you want me to kind of go through how to find them? Would that be helpful to refresh you? Yes, that's cool. It's like kind of do the thing where I know I'm hoping the answer is the thing. Yes, is what I wanted you to say. So thank you for giving me the chance. So how do we find A, B, and C? So I first said these two equals the original. My next guess, or step, would be to just multiply through by the original denominator. And then that gets us a nice flat equation. Because fractions, I mean, they're all well and good, but it's not easy to think like that. And that's really lovely. What would I do next? Or what could I do next? There's actually a couple routes to go here. Somebody help me out with one route. Yeah.
Could you set y equal to 0 and then solve for a?
Yeah, let's put some y. This is supposed to be true for all y. So let's plug in some y values. And we can't plug these in fraction form because we'll get division by 0. But down here, it's going to be sweet. So I'm going to let y equal 0. And that's one of the sweet values. The other one is y equals 1. That'll kill off a bunch of stuff. When y equals 0, I get a times 1 equals 1. Because that's 0 and that's 0. So awesome. I instantly know a. Love that. And now let's pick y equals 1. When y equals 1, I've got dead. Oh shit, that is nice. C equals 1. And I have 3 constants. How do I find b? Yeah.
Plug a and c in.
Yeah, definitely. I like that. Why not? Let's plug in A and C. You mean into here? Or where are you plugging them?
Well,
Sorry.
I would use because you know a and c now, so change those to 1s, and then
Yeah.
I guess you'd have to find some value for y to simplify it.
Yeah, exactly. So we still need to get one more value for y, but this is pretty nice. Writing this all out like this. So now we just plug in any other value for y, and we know b. What's a great value for y? What's the lowest hanging fruit besides 0 and 1?
-1.
Oh, a negative one's also a negative 1? There's even one a little bit better, 2. Because 2 minus 1 gets you 1. So, all good stuff, but let's let y equal 2. And then we get 1 squared plus b times 1 times, oh shit, yeah, that's good. B times 2 times 1, that's what I was saying wrong. Plus 2 equals 1. Settle down, buddy. Talking to myself. So that's 2b equals -2. I think B is -1. Check me out on that. Does it look like legit algebra? I'm getting one nod. Yeah, cool. So then I plug those back in, and this is going to become integral of 1 over y minus 1 over y minus 1 plus 1 over y minus 1 squared dy. And now this is going to be a natural log, and a power rule. And if I work this through, it would be this minus natural log y minus 1. Sorry, the pen's dying. And then this last one's a power rule. And you could check me on this, but I'm pretty dang sure it's going to turn into that. And that's our left side. And remember that our right side was just t plus c. So all together, I want to write this up because I want to say one more thing about it, and then we'll call it. So this was the integral of the left-hand side. And remember that right was t plus c. This is called an implicit solution. In other words, I know the relationship between t and y, but I don't have an explicit solution like we want. If I had to go to this, I don't think I can. I don't think I can actually solve this for y in terms of t. So, not possible, actually, I think, is probably the answer there. So sometimes you can get an implicit, sometimes you can't. If you can't get an explicit solution, we still understand how this thing works. We know that the curves go like this. And then remember, they were all positive in here. When you have an asymptote, a horizontal one, you leave it and approach it asymptotically, and then like so. So I know a lot about this, even though that's a beast, but I could go to Desmos and have it plot this implicitly for all sorts of different C's, and then I would see these different curves here. All right, friends, let's see. I think that's about all I wanted to start the hour with. Let's see, what do we got? Yeah, it's about a half an hour. Let's see, is there anything else? Oh, I got one more for you. And then we'll just, yeah, I'll be helping you out, whatever you got the need to have help with. So suppose that x dot, so that's dx dt, equals x minus 1 times x minus 2. This is an autonomous equation. We can make a really nice B field. I have a couple questions for you. Find the limit as t goes to infinity of x of t if, and we've got 3 different problems. X at 0 is 2, so we have that initial condition. We have this initial condition, and we have this initial condition. So remember, this is what I'm looking for, that long-term behavior. Let's just pull these things together. Don't try to solve it. You could, but you'll be miserable. Maybe I'll try to solve it while you work on those. I'll be miserable for us. I'm actually kind of jacked to do it, so. And if you get done with that early, please join. insight from it.
Neat.
So let's go back to this question that I gave you. And then I'll go through that. I think I would like to just quickly talk through that so you can see it. Can somebody tell us like what is a good procedure for answering these questions without solving this? What's the game? Sorry. Yeah, do you feel like talking about it or? Okay. Anybody want to talk me through how do I understand this equation without solving it? What can I do? There we go. That's all I'm looking for. Just draw the little lines. Make the little arrows and shit. Okay, so step one, but watch this. I'm going to do an intermediate step. I'm going to plot x dot versus x and make this intermediate graph that really helps me sketch the whole thing out. So that's just like a parabola with with intercepts at 1 and at 2. Right? When x is 1 or x is 2, x dot is 0, so that makes sense. It's a parabola that opens upward. And if you don't believe me, you could just plug in 3/2 or 1.5. You could plug in x equals 3 and then x equals 0, and you can see that we've got a shape roughly like that. Step 2 is convert that. There's a couple of ways to do this. One is we could just indicate on this x-axis the flow. So here, remember that this is the rate of change. If I'm between 1 and 2, dx dt is negative, so I would flow to the left. This is, let's write that in here. X dot is negative inside there, so it's decreasing. To the left of 1, x dot is positive. And to the right of 2, x dot is positive. So now I've got these equilibrium solutions. I see that I have a stable equilibrium at x equals 1 and an unstable equilibrium at x equals 2. So let's translate that into a D field. So here's 2, here's 1. That is a lot. I was kind of expecting a lot of you, Cormac, when yeah, there's a lot going on there. So I'm negative under here. No, easy, calm down, buddy. Talking to me. I'm positive there, so I'm flowing up, sorry. I'm flowing toward the equilibrium. And then I'm negative in here, flowing away from 2 and toward 1, and then we become positive again. And now it's pretty easy to answer these questions. If x at 0 is 2, where do I end up? 2, right? If you're on 2, it's an equilibrium solution. So here, x tends to 2. In fact, x never leaves 2. So we can say x is identically 2. See that triple equality? That's a hardcore equality. We're freaking definite about that. What about if x is 0 equals 1? What's my long-term behavior? 1, thank you. In fact, it doesn't ever leave 1, it's always there. What about x at 0 is 0? Long-term behavior? 1, thank you. Is it possible for x to go to infinity? Now, what would have to be the initial condition for x to fly to infinity? Yeah, exactly. Yep, just up here, right? Just up in this band. So if we had one last question here for what x naught does x at 0 equals x naught give limit as t goes to infinity of x of t equals infinity, then we just need x naught bigger than 2. We're good to go. That's really the only way that can happen. If you start down here, you end up tending toward 1. So the only way to get to infinity is to start up there. Cool. That's all I wanted to talk about. A little practicing that idea back and forth. And now let's just take the rest of the hour. If you're done with your homework, you could read the next section on Eulers, or you could go do whatever you damn well please. That's cool with me. But I'm just gonna answer questions now and help folks who need help. So does anyone need consultation on anything? Oh, awesome. Beautiful. Thank you. Give me a job. Okay, cool. So, oh. Yeah, let me talk about this one up here, because I think you're not alone. I've actually talked about this one a couple times. Which one is this? This is question 4. Hey, question 4 on the web work, homework 1, something I want to talk about, or wanted to talk about, and I have talked about with a couple of folks. So that problem looks something like this. Dx dt equals 1. And if you separate this, you just move the dt over and the cosine over, you will get this. And the only way to integrate that is to, I realize there's a secant squared there. So we've got secant squared of t dt, integrate up. Yay, not bad. Like so. And then what was the actual question? Let's see, that's not, oh, okay. What was your initial condition? So we're given, got down here. So you probably have some initial condition that says this, y at 37 equals tangent of 37. Everybody's got something like that. And what that's saying to us is that, think about what tangent looks like. So tangent, who did I have this conversation? Lou, did you and I talk about this? I feel like we might have, or with someone. Yeah, so yeah, that sounds about right. So tangent looks like this. It has a period of pi units, so this is minus pi over 2. I would honestly have, tangent's one of those graphs you should have a visual idea of. Just have it on a chart, but it comes up all the time. So this one goes like this, that hits right at pi. Notice it's 0 every pi unit, so this repeats like this. Out here, this would be 2 pi. Is that right? Yeah. 2 pi, and then this would be 5 pi over 2. So these asymptotes are at odd multiples of pi. Let me write that out. Asymptote at odd times pi over 2. That's the form of every asymptote. So this is y at 37. What you need to do for this problem is figure out where your initial condition lands. So somewhere out here is 37, and then I've got a height of tangent of 37 units high. I need to figure out what odd multiples of pi frame that initial condition. Because what we're trying to do is figure out where does my solution exist, and it exists all the way up to the left asymptote and all the way to the right. How do you figure that out? Well, lots of different ways, but keep in mind that pi is approximately 3. So 37, if I were going to write 37 as some multiple of pi, so whatever that is, over 2, I'm just trying to figure out where it falls. I could think of this as 3. And then I could multiply by 2/3 on the other side. So I've got 74/3 equals this. And then I crank this number out. And this is probably like what, 23 2/3 or something like that? 23 2/3, something like that. No. Could somebody just really quick do that for me, please?
It's almost 25.
It's almost 25, beautiful, cool, thank you. So it's roughly 25. It's like 25 and some change, right?
No, if you like, yeah.
Oh, it's under. So what is it exactly? Actually, let's just do this damn thing precisely. Something times pi. Can you just divide 74 by pi for me, please? Cool, awesome. So what I've done here is this is the multiples of pi over 2 that get me to my initial condition. So that means that to the right of me, in terms of odd multiples, well, to the left, we've got 23. So 23 pi over 2 is to the left of this number. And then I've got my 37 inside here. And then it must just be the next odd multiple to the right. Could you check me out on this too, actually? What is 25 pi over 2? Because it should just be a little bit more than 37, but not, significantly. I hope. I think it will be. Anybody got it? I just need a number. Just need a number. It's like this old man on the street begging for a damn number and nobody has one for him. Sad days.
Dark times.
Dark times, yeah. Yeah, it's really.
39.27.
Thank you. So, this number right here is approximately 39.27. And could you just really quickly, please, Lou, give me this one too?
Oh.
Either Lou, any Lou. I'll take
36.12.
36.12. So we can see a 37 lands between there. And so my interval of existence would be 23 pi halves to 25 pi halves. That's it. I'm just looking for the 2 asymptotes that straddle my initial condition. And I don't know if that helps, Moyne. Give it a shot, see how it goes. Yeah.
Lou, did you have a question?
No, you kind of looked like you did.
I have.
You have
So,
beautiful.
so
Yes, ma'am.
this one right here.
Oh, cool. This is a good hard one. Definitely. Yeah.
Thing.
Looking good.
That's that. And then I'm doing the.
Yeah, we want to do partial fractions, right?
Is
So
that the correct?
I don't
Do I
think.
don't need a. 'Cause I don't-
Oh, that is the right setup. Yeah, exactly. So what did you get for A? A is 1, B is -1. Let's just double check that. Yeah. Actually, let's see this real quick. I feel like that might get us a -1 on top. So let's see how you did this. So you cleared it out. You got B times Y plus A times that looks good equals 1. So when Y equals 1, B equals 1. Okay. Yeah, I don't know why my brain is trying that.
Y
Yeah.
equals 0.
Yeah. So then A is -1. Yeah. So let's see. So let's rewrite this as -1 for Y plus 1 for Y minus 1. Yeah. Okay. You're right. Yep. That's beautiful.
Okay.
So now we've got.
Now you've got
Yes.
that.
Yes. Hey, this is looking good. And do you want to kind of talk about how to proceed from here?
Yes.
Okay, let me do that. I'll do that for everybody. because that was one of the harder problems on here as well.
So thank you for asking.
Which problem is that?
6.
Number 6. Cool.
Now, in number 6, everyone will eventually head to the same route. And at some point, you'll get this.
And Lou, let me make sure that I copied that down correctly, is that right? Okay, cool. But you have to find why. So now that original one, we did one kind of like this earlier, but it was way eviler. This one's not as evil. We can do this, but it's a trick that you might not think of. So step 1 is, I want to undo the natural log. You cannot undo the natural log unless it's a single natural log. So what I'm going to use here is the property that natural log of something minus the natural log of something else is the log of the quotients. So that's step 1, is to get that left side as a single natural log. And when we do that, we get that. So that's step 1, Lou. Get that. And I'll probably actually work this all the way through for you, except for the initial conditions. Because I like this one. So now I can undo this because once I have that, that is equivalent to this thing equals e to the triangle. So that means y over y minus 1 equals e to the t plus c. And this will become c e to the t. Does that part make sense? Lou, are you cool on that? Yeah, do that trick where it's e to the c and then I just call it c again. Awesome. And so I'm going to take off the absolute values because if this is positive, I'll make c positive. If this is negative, it's all good. So how do I find y? Well, first thing I do is multiply both sides. I'm going to flatten this out. I'm going to multiply by y minus 1. Does that sound good? Yeah. And then distribute like that. You know if any of this doesn't make sense. Yeah. And now I'm going to move this y term to the other side. So I'm going to subtract ce to the t times y from both sides. Let's move that critter to the left. Let me know how you feel about that. Sound good? Awesome. So now I can factor the y out of the left side, and I've got 1 minus ce to the t equals negative ce to the t. You know? Yeah? Feel good? Okay? And then divide by this. So this is y equals negative ce to the t over 1 minus ce to the t. And that's a beautiful solution.
And then with the initial values,
Yep.
you just plug in the t.
Yeah, what do you have for your initial condition?
So y0 equals 12.
Cool. So yeah, just so this would become 12 equals this. To find c, you almost kind of have to do what we did before. You have to multiply both sides by this and then find c. Does that sound good? Work on it a few and then I'll check on you. Cool. Hey, but everyone, for number 6, this is your solution. You just have to find c. And that could be made prettier. I don't like the way it's got that negative in the top. I like this version's way better. Just put that negative in the top and bottom. So much prettier. So yeah, I'll let you have some fun there. Got lots of time. Anybody else, anybody need consultations? Did you work on that, circle?
No, I got the new one. I have a question about that. Did you
Sure.
multiply by -1? Couldn't the C just take up the negative on the top?
So that's a really good question. Once I've got the C melded in here, if I start absorbing in
Well,
some places.
I meant like you could do that before you did that division.
Oh, yeah, yeah, as long as I'm consistent about it, so replace this, so suck the minus in here, make
Yeah.
that a plus, and then just make that a
Yeah.
plus. Now I'm starting to be concerned, hold on.
With the 1 plus CE to the T, that's how I got it. That's what mine was in the form of.
Yeah, and I think that'll work out fine,
Alright.
yeah. Yeah, so you had C to the T plus 1 in the bottom?
Yeah.
That's okay, yeah, because we don't know if your C will come out different than mine, but when you plug it back in, we'll have the same answer. Yeah.
I get how you got that.
You see?
Yeah.
Awesome.
0.
Yeah. Good. Talk about.
I'm trying this one more, but.
Okay, let me know.
Yeah, I had to go back in for, you're doing 6? Yeah, I had to go back and watch one of your lectures from like last year.
Oh geez, which one?
About the interval. I had to
Oh,
like,
did I have a lecture on that?
Well, you had, like, somebody had asked a homework question that was very similar about
Dang.
finding the interval, and so I went and dug that up,
Oh,
and I was
nice.
like,
I did put a, did you see, I did put a solution. That's awesome you did
yeah,
that, but
no,
boy,
I
that's a lot
found
of
that,
work.
I found that one too, and
Okay,
it was
cool.
harder with, like, pi, I was like not understanding it
Got
based
it.
on that sheet, and I
Got
was
it.
like, I don't know what's happening.
You feel good about it now, though?
Yeah.
Awesome, cool. Ladies, are we good? Anything you need help with? Okay, cool, awesome. Yeah, let's just make that homework due by Friday at 2 p.m. in my box, since I don't see any rush to get it done on Wednesday. Did you have a question?
Yeah.
Yes, yeah, Phil. Okay.
When I'm making the other graph for the derivative fits respect to x, when I get to this point, I plot the points, how do I realize like how the graph actually
Yeah,
is?
let me go do an example up on the board. So one thing you could do is like go to Desmos and plot y equals that equation, and that would give you a sense. But let's talk about how to do that without a computer friend. Oh, a computer friend is a fine friend. Nothing wrong with a robot friend. So let's say I had, and I kind of want to tweak it a little bit to show you something that I don't think you got in your solution. Let's do 3 minus. Let's say I had something like this. A little bit different than what you have, but kind of the same.
Right.
So the first thing I would notice is this can be factored,
Okay.
because that's the difference of 2 squares, so that's this. And so on yours, you're missing one of the equilibria. And then once I've got this, and I'm trying to get this phase diagram here, I would first just mark off the equilibria. So at 2, and at 3, and at minus 2. Let me know when you're feeling cool about that. Yeah. So then, this is a polynomial of some kind, right? It's, you know, it's got the basic polynomial shape. They all kind of look like that. They're just squiggly lines. What I need to figure out is what kind do I have here? Well, it's first off, it's degree 3. Does that make sense? Yeah, like the highest degree is 3. So it's something like that, or like that, you know, that general cubic shape. To figure out which of those it is, I'm just gonna test some points here. So when x equals 0, am I above or below? So in other words, let me just make a little chart over here. When x is this, what is x dot? When x is 0, x dot is -4 times +3 is -12. So the graph in this region is underneath. And it doesn't matter if it's precise, I just need to know, is it above or below? Is that, yeah, you sure on that? Let me stop for a second.
Yeah, so I understand how you got the -12. Why did you connect it between those 2 points?
Yeah, so I know that, and so the only place this graph can jump across the x-axis is at these equilibria.
Okay.
That's the other fact that I'm kind of using that I didn't state. Does that make sense?
Yeah.
So what about in here? Are we positive? What should I test to see if I'm above or below inside here? What's a good x coordinate inside?
2.
2.5? Does that make sense? Because at 2 we know we're 0, and at 3 we know we're 0.
Yeah.
So when x is 2.5, let's do this casually. Look, I've got 2.5 minus 2. That is a positive number.
Yeah.
That's a positive number. 3 minus 2.5, positive number. And so the result is positive. So I know that I'm positive inside here. I have to be 0 on the ends, so it must look something like that.
Okay.
Is this kind of making sense? Yeah. And then test a point out here, so that's 2, 3. When x equals 4, positive, positive, negative. Let me make sure you're seeing that. When x is 4, that's positive, positive, and a negative.
Yeah.
So I'm underneath.
Okay.
And then over here, I could test a point and I could convince myself that it looks like that. Does that sound good?
Yeah.
Okay, awesome. That's what we're here for. Oh, boy, did you have a question? Sorry. Yeah. Okay, yeah, it's not, oh, you want a whole number. That's the problem. And it should be 2 consecutive, so, here put, 7, let's try 7, but then that one should be it's gotta be 2 consecutive odd multiples, so it should be 7 and 9 pi over 2, or, did that work? Shit. Do you see what I'm, okay, cool, you're good.
So I got these ones, but how do I solve for t for the equation? Do I use this same part here to solve for t? Is it equal to 3?
What do we have to
The question
do?
is this one. So normally we found y.
Oh, yes, so we would have to solve that for t. You want me to kind of do an example on that?
Yeah.
Okay, you got it. So. And have we already, by this point, did we already figure out what c needed to be?
Yeah, I
Okay.
found that from my other values. It's
Cool.
Just,
What'd you get for yours? Oh, it's god awful.
yeah, it's pretty ugly. but it's
Okay.
Wait, what you, yeah,
So this is problem, what, sorry,
It's the same 1, 6.
6, this number 6, the last part,
It's a B.
or part B?
Yeah.
Oh, okay, it's okay, I'm really firing blanks there. So what we need to do, once you found your C, you need to find the T, and Trace said yours was 3 or something like that, right? So once you know your C, set these two equal. And then you kind of gotta do the game backwards. So multiply both sides by this. don't absorb into the C at this point. So I just took that times 3, wrote that over here.
Yeah.
And then subtract this from both sides. So we got negative 2c e to the t equals negative 3. Divide by that negative 2c, so I get e to the t equals 3 over 2c.
Why negative 2?
Because I subtracted this from each side, Lou. I took minus 3c e to the t off both sides. So
Alright.
here's, is that make, so here's 1 and I took off 3, yeah. So then here, it's just the natural log of 3 over 2c, which should work for everybody, no matter what. Well, I guess it depends on what your initial, I guess it depends on your problem. But does that make sense, Tracy?
Yeah, that makes
Okay,
sense.
awesome.
Thank you.
You're welcome. Tara, did you have a question? I felt like you did just seconds ago.
Yeah,
Cool.
14, I'm just struggling on like how to set it up, or like know how to set it up and then.
Cool. Let me give an example. That's problem 14.
Yeah,
Okay. So in problem 14, we've got something like this, y prime equals, and it's a lot like what we did at the very beginning of the hour, but let's just take a look at it again freshly. Let's say I have that. So the first thing I would do, and then they give us what happens, is it long-term for those?
it just says to sketch the.
Oh, just
solution.
sketch the
That part was what
solution.
was
Got
confusing me
it.
versus the long term.
So what I would first do, almost, this is autonomous. Anytime I have an autonomous DE, I would make this chart.
Okay.
So you can see here when y equals 7 halves, 3.5, y prime is 0. And then I make this graph. So this is a slope -2 line, so it's gonna look something like that. And it doesn't matter what the precise stuff is. All that matters is, am I above or below the axis here? So does this sound good?
Yeah.
Yeah.
So far I have that.
Okay, awesome, cool, cool. So then I would transfer this into a direction field. And we have equilibrium only at 3 halves. So right at 3 halves, I'm gonna put a dotted line. I'm gonna tack on my arrows. And then look over here. So here we see that y prime is negative when y is bigger than 3 halves. Does that make sense?
Yeah.
Yeah, so over here, so that means up here it's like this. It's a negative slope. And then it's actually y prime is positive when y is less than 3 halves. So it's like this, it's got a positive slope under there. And now I can just kind of wing it. So for example, if it said the solution y at 0 was 1, that would be right here. And following the flow, I would become asymptotic to that equilibrium.
Okay, that makes sense. I was just confused on how to bring that piece together.
Is that, you're all good now?
Yeah,
Awesome,
thank you.
great question. Run to the restroom really fast, I'll be right back. So is your question, what's wrong with that? Or what is your question? I'm sorry, I just don't understand what you're asking. Do you want me to check that, or, yeah, what's happening here? Because it's clearly wrong, right? But, yeah, how did you get that? Let's see. So you took, yeah, let's see. Yeah, exactly. Yeah, so let's take this. So yeah, it's going to be this top one. So you were working with the right one.
Yeah.
Because that's the one that's positive. So that makes sense. So let's see. So we've got. Yeah, let's just work it through here.
And then it's gonna be, we're gonna wanna take.
So this is the problem here. What should this? So here we have 1c minus 6c. That's negative 5c. So I think that's probably part of the problem. And then what do we have? Equals negative 6. Yep. So e to the t equals 6 over 5c. And now whatever your c turned into, which I think you got, I think it's like 12 11ths. Let's just try that. So there shouldn't be a natural log, actually.
Really?
I don't think so. Oh, right, because that's e to the t. Yeah, you're right. Yeah. Oh, and I think we need more parentheses. Because that, so one to the left,
No,
yeah, to the left of the 5.
to the left.
Because this is all in the denominator, right? That 5 times 12 11ths is all in the denominator, and then one more on the right. Let's try that.
Okay.
Boo.
Booyah.
Booyah.
And then one just.
I would do a little plot, but it's gonna become infinite when this bottom is 0. So when that denominator goes to 0, that, you need to find the t that makes that happen. So try that. Yeah, does that make sense? Cool over here, you doing all right? Oh, you have a question? Oh, we finished. Oh, enjoy the rest of the day. Cool. Gentlemen, everything cool? Okay. How's everything here? You got some other shit going on. Oh, that
Yeah.
looks horrible.
Yeah, it is horrible.
What is that for?
It's for
RA?
Yeah.
Oh,
You want this?
sure. Oh yeah, if you have your homework, I'll take it. You can turn it in all the way up to Friday.
I still can't find it on roll class,
Can't find
the.
the
written-
assignment. Okay, let's go to world class. Go to our course. There you go. Come over here. Click, why is it not showing? That's quite odd. Go to assignments. There you go. But that's, why is it? No, that's just. What the heck, Lou? Can I just like look really quick? Thank you. It's not showing anymore for some reason. So that was the first one. What the heck? Weird. Let me go. I don't know what the fuck is going on. Shocking
because I need to use my phone,
Yeah, your phone isn't.
and my phone is recording things. I mean, Distella's in the recording, you know. Call that recording good for the day.